Hi everybody. I thought I would use UML in order to illustrate the notion of classes. Here we have the extends relationship shown in blue. There is a thing in Java which we call the primitive data type. These are built-in data types in Java. In Java, you don't get to create your own primitive data type. And I like to categorize the primitive data types into numeric and non-numeric. In the numeric data types, I like to categorize them into floating point and fixed point. With the non-numeric data types, I like to characterize them as Boolean and character. The character uses 16 bits and is an unsigned Unicode character. A Boolean can have value of true or false. Within the floating point data types, we have 64-bit double precision floats, and we have single precision 32-bit floats. Within the fixed point data types, we go in powers of 8. We have an 8-bit signed byte quantity, a 16-bit signed short quantity, a 32-bit integer, and we have a that's a signed integer, and a 64-bit signed long. With each one of these data types, what I have done is I've defined a reference data type with a name. So when you see something like primitive data types, if you look at it, you can see, aha, there is a class called primitive data types. If you see something like numeric data types, you can go over to, see if we can bring that up, numeric data types, and we say it extends or subclasses the primitive data types. Back in the day of Simula, when Straussup first encountered the notion of classes, the classes were short for classification. And so what we think about when we think about a set is we think about a superset and then a subset. The cardinality of the superset, that is the number of items in the superset, is in general always larger than the cardinality of the subset. So what we can say here is that with non-overlapping subsets, we have an AKO hierarchy. That is to say, a kind of hierarchy, so that numeric data types are a kind of primitive data type. Non-numeric data types are also a kind of primitive data type. And the fixed point data types are a kind of numeric data types, and the Boolean data types are kind of non-numeric data types. Note that each one of the arcs is got a direction, and there are no cycles in this graph. Cycles in the graph would be connections between the leaves. Thus, we say this is a directed graph and that it is acyclic or without cycles. Or, in short, we say it's an acyclic digraph. This represents a taxonomy, which basically divides all the different types of primitive data types into separate categories. While it is possible to convert one category to another, when you tend to lose information, such as going from a 64-bit quantity to a 32-bit quantity, you must instruct the compiler to explicitly do the casting. Whereas if you want to go from a 32-bit quantity to a 64-bit quantity, the conversion can be automatic. And let's see, what else can we say about these things? Floating point types are numeric. Subclasses of floats include 64-bit and 32-bit. And so now you can see all the different types represented as classes. Now within the float, you could actually put in a float. Here's a float. Float f equals, I don't know, make up a number, 20.0. Now that doesn't work. The literal 20.0 looks like a double. But if you put an f next to it, it identifies it as a float. Let's try and do the same thing with a double now. We'll take the double and we'll set it equal to 64.0, and that works fine. Suppose we make it a float. No problem, because converting from a float to a double doesn't cause any loss of information. So no casting is required. Suppose we had an 8-bit quantity, the byte, and we set it equal to 127. No problem. Now suppose we said 127.0. Well, that's a problem, because that looks like a double precision float. So if you want to make it into a byte, you have to call byte, and that will do the casting. So the compiler will let you do the assignment, but it will require, if you're going to lose data, that you do explicit casting. And that is how you use the primitive data types in Java. Short version.